Good morning, everyone. Today we will revise fifth unit introduction. The topics from fifth unit are boiling and condensation, and we have radiation on the other side, the second part of fifth unit. So now, coming to boiling and condensation. What's boiling? Boiling, or it can be a condensation. It's all a convective processes. They are specific convective processes. See, what's the boiling? Boiling, it is the convective heat transfer. The convective heat transfer process that involves a phase change from liquid to vapor state. What is boiling? Boiling is nothing but the conversion of a liquid to a vapor. Phase change is taking place. It is because of the change of phase with the supply of latent heat. We call it as latent heat of vaporization. It is changing its phase from a liquid to a vapor. Coming to this graph, which is very important, temperature versus entropy, TS graph. For a pure substance, now it is water. If I consider if it is water, now we know that the right portion is superheated region, and we know on constant pressure lines we can see when we from the liquid phase to the vapor phase, the conversion of the liquid to the vapor, we need to supply HFG. We call it as latent heat from fluid to gas. Latent heat of vaporization is what we call. This we have seen. This we have seen in second year itself in thermodynamic subject. Now, in general, you have a hot surface and we have a liquid. Say it is water. When the temperature of the surface increases, keep on increasing, the lower layers, the bottom layers will get heated up, and meanwhile it is because of the convection the process is taking place, and due to the convection currents we know that the complete liquid will get heated up, but this goes in a procedure and in a process. Now here the surface temperature, say Ts, is greater than the saturation temperature of the liquid. The liquid, for getting boiling, for converting liquid to vapor, the surface temperature must be greater than the saturation temperature. We need to remember this point. Saturation temperature of the liquid, say for water at atmospheric pressure, it is 100 degrees Celsius. In order to convert the liquid form of water to vapor form, it requires the surface temperature should be greater than the saturation temperature. See, the boiling takes place at interface of the surface and liquid, where the surface temperature is greater than the saturation temperature, and the amount of heat transfer Q is equals to HA Ts minus T saturation. We know this is from the convection equation. Heat transfer, convective heat transfer, Q equals to HA delta T, where delta T is surface temperature minus saturation temperature, and Ts minus T saturation is called as excess temperature delta T. I think it is clear. Now again, once again, see what we have discussed. We have discussed only about boiling. What is boiling? The conversion of a liquid, conversion of a pure substance from liquid phase to a vapor phase. That is what we call boiling. And we have seen, for boiling, to convert one phase to other phase, the surface temperature must be greater than the saturation temperature. Saturation temperature of that particular liquid, it can be water, ammonia, or any other liquid. For boiling, the surface temperature must be greater than the saturation temperature. This point we need to remember. Next, now types of boiling. There are 4 types of boiling, namely one is Pool boiling, it is purely said that it is natural convection. Forced convection boiling, subcooled or local boiling, and we have one more type, the fourth one, saturated boiling. Now let us see what is this first type. Pool boiling. In natural convection, what happens, we require a hot surface. Definitely we require a hot surface for boiling purpose. We require some heating source, say that is hot surface here, and you have stagnant liquid on the both sides. It can be on the both sides. Stagnant liquid, it is, the liquid is stagnant, it has no velocity. Liquid velocity is zero initially. Later the movement in the liquid particles will take place due to the convection currents. And in one of our experiments in heat transfer lab, that is critical heat flux, for determining critical heat flux, we have observed, I told, to observe pool boiling. What is pool boiling? There we have seen a wire is kept inside a liquid, and we keep on increasing the temperature of that wire. And what happens? The same boiling process takes place when the temperature of that surface, a cylindrical wire surface, is greater than the saturation temperature of the liquid. Then the boiling starts. We have observed a sort of bubbles that are coming up. We have seen that. So that is called as pool boiling. It's very simple. In general, we know that. One more example is a heater. Water heater is also an example for pool boiling. We keep the hot surface inside a liquid, stagnant liquid, and we keep on increasing the temperature, and the temperature transmission takes place, or heat transfer takes place from the hot surface to the liquid, stagnant liquid. That is pool boiling. And next, forced convection boiling. By means of pumps, the water is made to flow over the hot surface. Water tube boilers. By means of pumps, remember, the name itself, forced convection itself, says that the liquid has got some velocity. Now, forcibly we allow the liquid over a hot surface. And one of the examples is water tube boilers. Water tube boilers means inside there are, you have tubes. Through the tubes water is flowing. Outside of the tubes we have flue gases. It is inside a furnace, like a big chamber. You have this tubes, and through the tubes water is flowing in one direction. Meanwhile at the end you will get water converted to the liquid phase, converted to the vapor phase. So forcibly we are allowing the liquid to move through the tubes. That is forced convection boiling. Next, the third type, subcooled or local boiling. The bubbles formed at the hot surface travel towards the top layers of water, gets condensed due to less water temperature. Very simple. Now take a container, and what we will do, we have a liquid here. We start heating up from the bottom. The surface will get heated up. When as soon as the surface temperature reaches the higher temperature, greater temperature than the liquid, the heat transfer takes place from the surface to the liquids. And if the surface temperature is almost greater than saturation temperature of the liquid, it will start forming the bubbles, and these bubbles will slowly rise up due to less density. It will move up. And what happens when it is moving up? Those hot bubbles must be condensed, or they must be cooled by the top layers, which are at low temperature than the bottom layers. Meanwhile, these bubbles, before reaching to the topmost layers, it will get condensed. See, it is written here, the bubbles condensed before it reaches the top layers of water, top layers of the liquid. They will get dispersed. it will diffuses. The energy is getting diffused to the layers, the top layers, before it the bubble coming out. Before the bubble comes out of the topmost layer, it will get diffused within the liquid. That is subcooled or local boiling type. Next, the other type, the last type, saturated boiling. So in subcooled boiling, the bubbles will not come out, whereas in saturated boiling, the bubbles will come up. Bubbles are coming up and forming the vapors. These vapors can be further used for different purposes. It can be for heating purpose, or it can be sent to a turbine in a power plants. It's a different story. So in a saturated boiling, the bubbles formed will propel through the liquid. The bubbles formed will propel through the liquid by buoyancy effect and escapes into free surface, and we call it as vapors. You can observe the figure. The bubbles are rising up and they are escaping into the free surface. They're coming out. Just you need to observe these things. So let me revise. What we have discussed is, we just started fifth unit. There is boiling and condensation. In boiling, we know that the conversion of a liquid to a vapor with the supply of latent heat of vaporization, where the temperature of the surface greater than the saturation temperature, and the boiling process takes place. Next, we have seen the types of boilings: cool boiling, forced convection boiling, subcooled or local boiling, and the fourth type is saturated boiling. So just go through these points, and again we will continue our class with boiling regimes, especially for pool boiling. In boiling regimes, you will see what are the stages, how it is getting boiled, when how it is the liquid is getting converted to a complete vapor. So what are the stages? You have interface evaporation state, next nucleate boiling second and third stage, film boiling fourth and fifth stage, the last one is sixth. We have stage 1 in interface evaporation. Nucleate boiling, we have two stages, and in film boiling we have three stages. And this graph is Q, that is heat flux. We call this as critical heat flux. You all drawn the graphs in heat transfer lab that we have. I have already told you to observe the pool boiling. See, this is pool boiling. So in pool boiling, we have drawn the graph between critical heat flux versus delta T, excess temperature, surface temperature minus saturation temperature. The curve goes up, it rises up like this only. Yeah. Now, coming to the stages, you need to draw this figure onto your notes at least once. Now, in interface evaporation, let us discuss about the stages. In interface evaporation or boiling, it is the pool boiling where the convection currents are just observed, just the convection started, just the convection started. So in interface boiling, we simply just observe. We have taken a big container, we have started heating from the bottom. So what happens? Slowly the heat transfer takes place to the surface to the liquid, and we can observe uh, convection currents. It just starts. Next, that is in interface boiling. Next, this in nucleate boiling, we have second and third stage. In second stage, bubbles condense in superheated liquid. whatever the bubbles are formed, it will get condensed. It will not escape out. It will get condensed within the superheated liquid. Next, third one, bubbles rise to the top surface. Next, in third stage means this one here. As soon as it reaches to peaks up critical heat flux, where the critical heat flux is getting the third stage, the bubbles are almost they reaches the top surface. Next, in film boiling, there are 4, 5, 6 stages. In fourth stage, bubbles coalesce, coalesce, coalesce to form a film which is unstable. They form a layer. They all, and it will become a unstable bubble. Nature will form. You can see a unstable form. Next, fifth one, again on continuous heating continues in forming bubbles, and the film strength increases. The film becomes a stable film. Now again on continuous heating, all of a sudden the complete liquid get converted to the vapor and radiation starts. You can observe a radiation from the liquid, from the vapors to the outside. So these are the main stages. There is 1, 2, 3, 4, 5, 6 different stages that can be observed on continuous heating when the excess temperature keeps on increasing. And when we keeps on increasing, the heat flux enters. First it rises up, it reaches to the critical heat flux in the third stage, and it will come down because of the formation of the films of the bubbles. The bubbles will act as some a part of what we call insulators for heat transfer. So it will not allow the heat flux to pass at a maximum rate to the liquid, but all of a sudden all the film will get broken up, and it will get converted to the last stage is the radiation, where the complete liquid gets converted to the vapor, and heat flux is maximum at the final stage. And we have seen what is a critical heat flux. Just a small definition for critical heat flux: the point of maximum heat flux on the boiling curve at which transition from nucleate boiling to film boiling initiates. The transition from nucleate, see, the transition from the nucleate boiling to the film boiling initiates at that particular point. Whatever the heat transfer is taking place to the liquid is known as critical heat flux. That is, here you see, in nucleate boiling to film boiling, that transition is taking place from third stage to fourth stage. At that peak point is called as critical heat flux. The point in the boiling curve, boiling regimes we call, important to remember boiling regimes. The point at which the maximum heat transfer is taking place, or we can say the point at which the curve changes its direction from nucleate boiling to film boiling, is known as critical heat flux. Correlations from data book. Now you do one work. It is nucleate pool boiling, critical heat flux from nucleate pool boiling, film pool boiling. For these three, you will get relations from data book. Just do, if you have data books, just go through it, and we will continue. When you see these correlations, then this boiling is over. This boiling topic is over, and we left with condensation. Very simple. But the thing is, you should know how to use the data book. So some part of theory is there, so theory can be covered. And for coming to the problems, you must watch, or you must go through the data book for the relations, as I said. And this PDF, you are already having this PDF. Go through this PDF, and any doubts, without any hesitation, just try to contact me personally and get your doubts clarified. Thank you.